So let's work on these 6 problems on arithmetic progression. In the first problem, we need to show that the 3m plus 1th term of an AP is twice the m plus n plus 1th term whenever m plus 1th term is twice the n plus 1th term. So let's begin. So first, we will consider the first term and the common difference. We'll assume that the first term of the AP is represented by the letter A in its lowercase, and the common difference will be represented by the letter D in lowercase. So here it's given that we have an AP arithmetic progression. In that progression, the m plus 1th term, that means am plus 1, this is equals to 2 times the n plus 1th term. So this is given to us, and using this particular information, we need to show that the 3m plus 1th term, this must be equals to 2 times the m plus n plus 1th term. So let's begin. So first we'll start with whatever has been provided to us. So here we will use the general formula for finding out the nth term of an arithmetic progression, which is given by a, the first term, plus n minus 1 times the common difference d. This would mean that the m plus 1th term will be a plus, in place of n we have m plus 1 minus 1 times the common difference d. So this will be equals to 2 multiplied to n plus 1th term. So that's a plus n plus 1 minus 1 times the common difference d. So here we have a plus, so m plus 1 minus 1, that's simply a plus md. This will be equals to 2 multiplied to a plus nd. Right. So this gives us a plus m times d equals to 2a plus 2 times nd. So we can transpose all the two terms from the left hand side to the right hand side and rewrite the equation as a plus 2nd minus md equals to 0. So we'll set it aside for the time being. We'll come back to it in a moment. We'll label this as equation number 1. Now we have to show that the 3m plus 1th term is equals to 2 times m plus n plus 1th term. Now what will be the 3m plus 1th term? So this will simply equals to a plus 3m plus 1 minus 1 times d. So here we have to use this particular general form. So this gives us a plus 3md. So this is our 3m plus 1th term. We'll label this as equation number 2. And then we have the m plus n plus nth term. So this is a of m plus n plus 1th term. So this will be equals to a plus m plus n plus 1 minus 1. So this is simply m plus n times d. So this is going to be equation number 3. So let's start from, let's say, from the right hand side. We'll consider this. This is what we need to prove. We'll start from the right hand side. So on the right hand side we have 2 times d m plus n plus 1th term. So that means we have 2 times a plus m plus n times d. So this will be equals to 2a plus 2 times m plus n times d. Let's further simplify. So we have, so we can split a into 2 parts. So we can write it as a plus a. Then we have 2 times m times d plus 2 times n times d. Right. Now if we look at equation number 1, so here we can have a plus 2nd. So a plus 2nd, this will be equals to md. So we can replace a plus 2nd with md such that we have a plus, so this 2md is already present. To it we are going to add this md, and this is obtained by combining a and 2nd. That means the second and the fourth term. This gives us a plus 3md, and this is what a plus 3md according to equation number 2. This is a of 3m plus 1. That means this is the 3m plus 1th term. So that means we have shown that this is equals to the left hand side. Hence, we have successfully showed that 2 times dm plus n plus 1th term, this is equals to 3m plus 1th term whenever we have the condition that the m plus 1th term is equals to 2 times the n plus 1th term. So let's move on to the next problem. So in problem number 2, we need to find the value of n, and it's given that the nth term of these two AP are exactly the same. So let's begin. So we will assume that the first term, that's represented by the letter A in lowercase, and the common difference is given by the letter D in lowercase. Now for the first AP, which is given by 15, 12, 9, this has a common difference of 12 minus 15, which will be negative 3. And the first term of this particular AP is 15. Then our nth term will be given by, we have our first term, which is 15. So we have 15 plus n minus 1 times the common difference, which is negative 3. So this will give us 15 minus negative 3n plus 3, or simply 18 minus 3n. So this is the nth term of this particular AP. Now we'll consider the other AP, which is 9, 7, 5. This goes on. So here this is our first term with a value of 9. Our common difference will be 7 minus 9, which is equals to negative 2. So that means its nth term will be equals to 9 plus n minus 1 times negative 2, which gives us 9 minus 2n plus 2, or simply 11 minus 2n. Now, according to question, it's given here that this particular nth term, this is 18 minus 3n, this is equals to the nth term of this AP, which is 11 minus 2n. So that means we will have 18 minus 11 equals to 3n minus 2n, or simply n equals to 18 minus 11, that's 7. So that means the value of n is 7. Let's go to the next problem. Now in problem number 3, we need to find out the first term and the common difference, and it's given here that the fourth term of the AP is equals to 3 times the first term, and the seventh term of the AP, it exceeds twice the third term by 1. So let's begin. So let's begin by first considering the first term. We are going to represent the first term with the letter A in lowercase and the common difference with the letter D in lowercase. So let's state whatever is provided to us. Here we are given that the fourth term, that means A4, is equals to 3 times the first term. So our first term is simply, so that means A4 equals to 3A. And we are also given the second condition, that means the seventh term. So this is the seventh term, A7. It's exceeding twice the third term by 1. So this is the second equation. Now we will use the general term equation, which is given by A plus n minus 1 times D. So that means we have here the fourth term will be A plus 4 minus 1 times D. So this will be equals to 3A. So we have A plus 3D. So that's equals to 3A, or simply 3D equals to 3A minus A. 3D equals to 2A, and solving for A, we have 3 over 2D. We will label this as number 1. Then coming to the second one, which is the seventh term equals to twice the third term plus 1. So here we'll have A plus, so 7 will become 6D equals to 2 times we have the third term, so this will be A plus 2D plus 1. Let's simplify it. So here we have A plus 6D equals to 2A plus 4D plus 1. So we'll transpose 4D to the left hand side. So we'll have 6D minus 4D to give us 2D. Thus A will go to the right hand side to give us A plus 1. Now we'll substitute the value of A with 3 over 2D. So we have 2D equals to 3 over 2D plus 1. So here we have used equation number 1. Now what we'll do, we'll multiply throughout with 2. So we get 4D equals to 3D plus 2. And 4D minus 3D will be D. So this is solving for D. We get D equals to 2. So we have obtained the common difference, and we can substitute this value back into equation number 1, which will give us the value of a. So a will be 3 over 2 times the common difference, which is 2. So that means we have the first term given by 3. So this is the value of the first term, which is 3, and the common difference, which is 2. Let's move on to the next problem. So here it's given that the sixth term of an arithmetic progression is 12 and the eighth term is 22. We need to obtain the value of the second term as well as the nth term. So let's begin. So we will consider our first term to be equals to a, and we'll consider the common difference to be d. So here we have to find out the second term, and we also have to find out the nth term, and it's given here the sixth term. The sixth term is given as 12, and the eighth term has a value of 22. So let's begin. So we will use the general formula for an. So we know that the general form of an is given by a plus n minus 1 times d. In our case, we have sixth term, so this will become a plus 6 minus 1, that means 5d. So this will be equals to 12. And we have our eighth term, so this will become a plus 7d equals to 22. Now we'll label this as equation 1 and this one as equation number 2. And what we'll do, we'll subtract equation number 1 from equation number 2. It's going to give us 7d minus 5d, that will be equals to 22 minus 12. So 7 minus 5, that is 2. So we have 2d equals to 22 minus 12 will be 10. That means d value will be 10 over 2, which is 5. So we have our common difference with a value of 5. We can use equation number 1 to obtain the value of a. So a will be equals to 12 minus 5d. So d here is 5. So that means we have 12 minus 25, and this is going to give us the value negative 13. Fine. So now that we have the value of a common difference as well as the first term, we can obtain our second term. So our second term will be given by a plus d, which will be equals to, so our a value, that's negative 13. To it, we are going to add the common difference, that is 5. That means it's going to be negative 8. And the nth term will be given by a plus n minus 1 times d. So our a value is negative 13 plus n minus 1 times 5, which is negative 13 plus 5n minus 5, or simply 5n minus 18. So this is going to be the nth value, or the nth term of a given arithmetic progression, and negative 8 is going to be the second term of the given arithmetic progression. Let's move on to the next problem. Problem number 5. We have to find out the number of two digits number that are divisible by 3. So let's begin. Before solving this problem, first let's find out the lowest two-digit number and the highest two-digit number that are divisible by 3. So the lowest two-digit number that's divisible by 3 is going to be 12. And after 12, the next number that's divisible by 3 will be 15. So what's the highest two-digit number that's divisible by 3? That's 99. So here, our first term, that's 12, and our last term, which is our nth term, that's going to be 99. And what's the common difference? The common difference will be 15 minus 12, that's equals to 3. Now we will use the general formula. We have our nth term, an, given by a plus n minus 1 times d. So our task will be to find out the value of n. So our last term, an, that's 99, which is equals to a, which is the first term, that's 12, plus n minus 1 times the common difference, d. We have 99 equals to 12 plus 3n minus 3. We have 99 equals to, so 12 minus 3, that's 9, plus 3n. Or simply put, we have 3n equals to 99 minus 9, or 3n equals to 90. And n will be equals to 90 divided by 3, so that's 30. So that means our total of 30 two-digit numbers are there between 12 and 99, including both of them. And these numbers are divisible by the number 3. Now let's move on to the sixth and the final problem. So in problem number 6, we need to find out the value of the 32nd term of an arithmetic progression which consists of 60 terms, and its first term and the last term are given. They are 7 and 125 respectively. So let's begin. So here we will consider our first term. Let the first term be represented by the lowercase letter a, and this has a value of 7. Our last term, that's also given. We will consider the last term to be the nth term. This value is 125. And this has a total of 60 terms, so n value is 60. Now using this information, we have to find out the 32nd term. Fine. Now we know that our last term, so that's given by a plus n minus 1 times d. Our last term means the nth term. So here the nth term is 125. That's equals to our first term, which is 7, plus n, that's 60, minus 1 times d. So from this equation, we can obtain the value of our common difference d. So 125 minus 7, so this will be equals to 60 minus 1, that's 59, where 59d. So this will be equals 118 divided by 59. And 118 divided by 59, that's 2. So that means our common difference value is 2. Now, we can finally obtain the value of our 32nd term, which is given by a plus 32 minus 1 times d. So our first term, a, that value is 7, plus 32 minus 1 is 31, times the common difference, that's 2. So we have 7 plus 31 times 2 will be 62, which is 69. That means the 32nd term of this particular AP, which consists of 60 terms, its value will be going to be 69.